Algebra 2 ACP Review, First Semester 2010-2011, Inverse Function Problems. Inverse Function Problem 1. The inverse function f to the negative 1 of x is f to the negative 1 of x equals 1/3 x minus 2. Which function represents f of x? There are a lot of ways to do this one. Let's solve this one by graphing. First, place y equals 1/3 x minus 2 in y1. Graph the function. If the graph looks weird, you might try the standard window, which you can get by pressing zoom, then 6. Next, we go back to enter y equals x in y2. Graph the two functions together. I'll now trace y equals x in red to get a better look at the line of reflection. Now we'll go back to enter answer A, y equals 3x plus 6 in y3. Now we'll graph three functions together. This one looks pretty good. If we want to get the true perspective, we can go to zoom square by pressing zoom 5, shown here, and it looks even better as a reflection. We try the other answer choices. This one is answer B, y equals 3x minus 6, definitely not a reflection. After trying the other functions, we choose answer A. We can also find the inverses by switching x and y and then solving for y. Here we rewrite the function as y equals 1/3 x minus 2. Now we switch places of the x and y, so we have x equals 1/3 y minus 2. Now we'll swap sides, so we have 1/3 y minus 2 equals x. Next we add 2 to both sides of the equation. Negative 2 plus 2 cancel on the left side. We bring down 1/3 y equals x plus 2. Then we solve for y by multiplying the whole equation by 3. And that leaves us with y equals 3x plus 6, and that's, again, our answer A. Inverse function problem 2. The point 2, negative 6 is graphed on a coordinate plane. Which coordinate represents its inverse? There are different ways to do this problem as well, but probably the easiest way to do this is to take the original point 2, negative 6 and just switch the position of the x and y coordinates, so that x becomes y and y becomes x, and we have the coordinates negative 6, 2, and that would be answer D. Inverse function problem 3. For the plotted triangle ABC, which sets of ordered pairs are the inverse of triangle ABC? Again, many ways are available to do this problem. I think that since we have ordered pairs as answers, a good strategy would be to find the ordered pairs of points A, B, and C. The coordinates of A are 2, 3, the coordinates of B are 2, 8, and the coordinates of C are 4, 6. Then we can write the inverses of these coordinates right below them. A inverted becomes 3, 2, B becomes 8, 2, and C becomes 6, 4. And these inverse points match answer C. Inverse function problem 4. The graph of f of x is shown below. Which graph best represents its inverse function f to the negative 1 of x? Again, there are a lot of ways to do this problem, but I think that a good strategy would be to draw the original line onto each answer choice to see which one is the best reflection about the line y equals x. And here is the line drawn on graph A. And here is the line drawn on graph B. Here is the line drawn on graph C. And here is the line drawn on graph D. And where is that line y equals x that they must reflect about? I've drawn it here in black for all four answer choices. While answer B is pretty close, answer A is definitely the right answer. Inverse function problem 5. The table below represents f of x. Which table represents f to the negative 1 of x, the inverse function of f of x? I don't think this problem is very easy. Still, there are many ways to do it. I think that what I would do is take the table of f of x and reverse the coordinates, which I've done here in red. Now we'll look at each table. There is negative 1, 1 in the red coordinates, and it doesn't match the negative 1, 4 in the table here. So we can cross off answer A. And we look at the table for answer C, and it has negative 1, negative 2.5. And that doesn't match either, so we cross off C. Now for the table in B, we do have negative 1, 1, and that matches. Also, in table B, we have 1, 2 in the red table that matches the 1, 2 in the B table. And finally, we also have 3, 3 in the red table, and that matches the 3, 3 in the B table. And we see that on table D that 3, 3 does not match 3, 8. So we cross off D as well. B is undoubtedly a right answer. This concludes our problem set on inverse functions.